Hello, in this short movie we're going to look at the Nobel Prize in Physics for the year 1912, awarded to Niels Gustaf Dalén for his invention of the automatic valves designed to be used in combination with gas accumulators in lighthouses and buoys. Well, here you see one of his lighthouses. As you can see, it was set up in 1912 and it was in service until 1980 and then it was electrified. And it has worked that period without much maintenance, which was very important, of course, in the north. Rough weather, difficult to come there, so maintenance free is very useful. Here you see the sun valve on the lighthouse. We will see better pictures of this in the next movie when we speak about his deal about with his Nobel Prize lecture. But first, why he got the prize? This is coming from the official Nobel Prize site, as you can see. For centuries, lighthouses have made navigation safer, and in the 19th century, acetylene gas has been used to light their beacons. Gustaf Dalén developed a method for emitting short flashes of light, thereby reducing gas consumption. In 1907, he invented a regulating valve based on the difference in expansion between black and white metal rods. This so-called solar valve could extinguish beacons during daytime, saving more money. Okay, there's some biographical information, which is also from the official Nobel Prize site, slightly summarized by me. On his return to Sweden, Dalén carried out some research in Gothenburg and set up consulting engineering. He became technical chief of the Svenska Carbid och Acetylene AB, Swedish Carbide and Acetylene Limited, in 1901, and he later joined the gas accumulator company, where he became chief engineer in 1906. In 1909, the company was reorganized as Svenska Aktiebolaget Gasaccumulator. Hope I pronounced this correct. My Swedish is not great. Shorted AGA, Swedish Gas Accumulator Limited, with Dalén as managing director. In 1921, Dalén's company purchased the patent rights of the French invention of dissolved acetylene, and he began his work on automatic flashing beacons for lighthouses. His subsequent invention of the sun valve, which causes a beacon to light automatically at dusk and extinguish itself at dawn, enabled lighthouses to function perfectly and unattended for periods of up to a year. His invention of cylinder-filled with porous mass of asbestos and diatomaceous earth for storage of acetylene reduced considerably the hazards in handling this material, and its use in welding became safe. He also invented a mixer for providing a constant and correct balance of gas and air for the use in the incandescent mantle, and a device for removing broken mantles and replacing them by new ones. In 1912, whilst testing safely devices on cylinders of acetylene in an outdoor location, and when satisfactory safety precautions had been taken, a sudden explosion seriously injured Dalén and caused the loss of his eyesight. He recovered from his other injuries and, overcoming his great incapacity, continued his researches. He was awarded the contract for lighting the Panama Canal and later turned to the field of thermal techniques to invent the stove, now in universal use, which means cooking heat for 24 hours using only 8 pounds of coal. You see a newspaper clipping for later, for the accident he spoke about, wherein he lost his eyesight. He remained alive, but he was seriously injured. Then we go to the award ceremony speech by Professor H.E. Söderbaum, explaining why the prize was awarded. Again, summarized by me. The ever-growing use of maritime communication creates an increased demand for navigational safety devices. Among these devices, lighthouses and light buoys are of great importance, and their number has become several times greater during the last few decades. At the same time, efforts have been made to find ways of making their lights more powerful and their different lights more easily distinguishable. As far as possible, work has been directed towards finding a system which would regulate these lights automatically. This is a very important point, for no country is wealthy enough to maintain a continuous inspection of all its necessary light equipment. In Sweden, a country with a long coastline and large archipelagos, The problem of a reliable and fairly inexpensive lighting organization has for a long time been more pressing than elsewhere. About 1895, for the first time, it was discovered how to prepare acetylene from calcium carbide on a commercial scale. Acetylene is a gaseous hydrocarbon which, when burned, produces an extremely light and white light. The first attempts to use this gas for lighting in lighthouses did not have very satisfactory results. The petroleum gas in use for similar purpose up to this time had been compressed and enclosed in large iron containers. It was found extremely dangerous to treat acetylene in the same manner, as this gas, when under the pressure of one or more atmosphere, explodes at the slightest shock. It was also attempted to store calcium carbide in light buoys and let the acetylene escape under the action of water supplied automatically. Unfortunately, this method proved to be inconvenient, not very reliable, and unusable in cold water. In 1896, two French chemists, Claude and Hess, discovered that acetone possesses the property of dissolving large quantities of acetylene. This solution is not explosive. However, it cannot be used as it is to store acetylene because, even if the container is filled to the brim with a saturated solution under high pressure, the volume of the liquid is reduced by consumption or by cooling, and explosive acetylene gas is produced in the space above the surface of the liquid. It was then discovered that its explosive nature disappears if the acetylene solution is compressed into a porous mass. Numerous unsuccessful attempts were made to prepare such a porous mass which would be sufficiently resistant and elastic to withstand shocks encountered in transportation without cracking and crumbling, and thus producing cavities filled with explosive acetylene gas. The credit for the eventual discovery of such a mass, called agar, or porous substance, belongs to Gustaf Dalén. By a complicated and carefully developed process, this substance is enclosed in steel container, which thus become practical accumulators for the acetylene gas. The porous mass in the container is half filled with acetone, and acetylene is then introduced by compressing it to a pressure of 10 atmosphere. Under this pressure and at a temperature of 15 degrees Celsius, the container contains 100 times its own volume of acetylene. The container is then ready for supplying to a lighthouse or light buoy the acetylene necessary for lighting. The advantage of this arrangement would not be great if the acetylene light had to be burned uninterruptedly. On the one hand, this form of lighting would be quite costly, and on the other hand, it would be difficult to distinguish the lights of various lighthouses from another and from other light sources. True, several methods of producing an intermittent light were already known. For example, the flame can be surrounded by moving screens, or the light device itself can be made to rotate. But such an arrangement needs continual inspection and consequently involve considerable expense. Where compressed petroleum gas was used as a source of light, eclipsing or flashing lighting devices had ought to be constructed using the escaping gas as motive power. The flashes lasted 5 to 7 seconds, which was perhaps necessary because of the weak light output of the petroleum gas. But with the intense brightness of acetylene light, such long flashes become unnecessary. Furthermore, long flashes offer insufficient variation of the signal. Accordingly, the big lighthouses have generally replaced them with light-giving flashes lasting from 1/10 to 3/10 of a second. It was about 1904 that Dalén started to study this problem. With a petroleum gas apparatus, it was impossible to divide 1 liter of gas into more than 50 flashes. So Dalén constructed an apparatus based on an entirely new principle, which by instantaneous opening and closing of the gas pipe enabled 1 liter of gas to provide several thousand very rapid but distinct flashes. After a considerable trial period, this ingenious device proved to be extremely reliable. Dalén then provided a brilliant solution for the supplementary problem arising from the use of agar light in the lighthouse service, and an ever-increasing number of lighthouses and light buoys in Sweden have been adapted to this form of lighting. The burner is fitted with a small permanent flame in the most usual arrangement, lights a flash every 3 seconds, lasting 3/10 of a second. In 1907, Dalén crowned this achievement with a further refinement by design of a kind of valve called the solar valve, which extinguishes the light at sunrise and relights it when the night falls. This valve is controlled by 4 metal rods enclosed in a glass tube. The lower one is blacked, while the other ones are gilded and highly polished. Daylight is absorbed by the blackened rod, which is heated and consequently expands, closing the gas valve. As the data decreases, the black rod reaches the temperature of the other three rods. It contracts and allows the gas valve to reopen. The device can be regulated in such a way as to act with more or less sensitivity. To be on the safe side, it's usually regulated so that it lights as soon as mist or clouds cover the sun. The solar valve combined with an intermittent light produces a saving of gas of 93%, and even greater economy might be achieved by prolonging the periods between the flashes. Most of the maritime nations now have started to install Dalén devices, and now is of course 1912, and as said, these kind of arrangements were used until the late 70s, early 80s, when they were replaced by electric lighthouses. I don't think there are any more working today, but I'm not quite sure. Maybe there is. You see another of Dalén's adventures. He invented all kinds of things, regulators and flashers, for instance, and here he invented the famous Aga-cooker. Maybe you had one, or your parents or your grandparents. I remember my grandmother had such a device. Well, this is it for now. Next week we will continue with the Nobel Prize lecture by Dalén. But as I remember well from memory, he was not able to have a lecture because of the accident. So this will be replaced by an article on his achievements. For now, thank you for watching, and maybe till another time.